Okay, well that actually was advantageous that my computer freaked out because it's a separate recording for example 3A, and that's always nice. Okay, now we're recording. Zoomers, are we good? Or am I lagging? Zoomers, hello. Oh, there we go. Am I lagging or are we good? Okay, it looks like we're good. If I'm lagging too much, let me know, and I'll try to do what I can. Okay. So all of the files that go with my handouts are always going to be posted on the website right below the handout. In this class, I think most of it's going to be data that I can share with you, but if I can't share the data because it's someone else's, then I will post complete syntax and complete output. So the way that I have this structured is we have syntax for all 3 programs. I usually only show one set of output though, because the output looks pretty much the same. But inside that download packet, you can follow along with the original output in the other programs if you want to look at it. And if there's something that's odd or different enough to where I want to talk about it, then I tend to put it in the handout as well. So this is an overview of the code. It's not the whole thing. When you go to do your homework, by the way, do not copy from these PDF documents with the code. I found that that causes a bunch of problems in terms of the characters not rendering correctly or sometimes extra spaces being added. Start from the original syntax files in your program of choice and modify them from there. That would be my recommendation. Okay. Let's see here. So we have the first example here starts with a data set in which we have separate columns for pre-test and post-test and 1 row per child. So the very first thing that we have to do to be able to analyze these data in a longitudinal type multi-level package is to stack them. So this is something that all packages have a built-in routine to do to more or less painful degrees. So I will show you how to do that in each of the programs here to start with. So in the first part of this is SAS. I always define a program level variable for the file directory. This is equivalent to setting a working directory in R or in Stata, because then I can refer to any kind of file, whether it's a SAS file or not. Then I define a library for where the SAS data sets are. I import my data set, which is the exact same analysis as in chapter 3 of my book, by the way, so everything I'm about to say I already wrote down in the chapter. In SAS, the way that stacking works is via this output command that writes new data. So we are creating 2 new columns. One's called occasion, and the other is called outcome. And each one takes a different value in the original data set in terms of which column it was in. So the first time it goes through, it's going to pull the information from outcome 1, write a line of data. The next time it goes through, it's going to pull the information from outcome 2 instead, write another line of data in the same column. So when all is said and done, we will have 2 rows per person. One is going to have their outcome from pre-test and the other row has the outcome from post-test. And then we have this indicator variable that I've called occasion 1 and 2, just as literally just an ID variable for which row is which. And I drop the other variables that I don't need anymore. You don't have to do that, but it sometimes helps in large data sets. And I throw labels on there because I am a good data analyst who was trained that way. Last step then is to make the variables that we're going to use for this analysis. So in the original data set, group was coded 1, 2, which is not wrong, but that's going to cause a problem if I put that predictor into the model. Because the intercept in these models is always for the predictors when they're 0. Share screen again. Sorry, Zoomers. There we go. I'm on example 3A. That's where we're at. I just downloaded it from my own website. All right. Yes. So we can't have group 1, 2 because the intercept would then describe the predicted outcome for group 0, which doesn't exist. Likewise, we can't have occasion 1, 2 for the same reason, because we don't want the intercept to refer to occasion 0 that doesn't exist. So I'm making new versions of the variables that will then go into the models. I'm calling my pre-test, post-test variable time, and it's going to be 0 is pre-test, 1 is post-test. Likewise, I'm creating another variable called treat that takes a 1 if it's the treatment group and a 0 if it is the control group. So you could pick whichever of the 4 cells as your reference. I just did it this way because it makes the most sense to me. Okay, any questions on that much from the SAS folks? If there are any, I should say. All right, Stata folks, who in here uses Stata? 1 person, 2-ish Zoomers, any Stata folks in the house? A couple of you? Okay. So then you'll be more interested in this. I am doing the same sort of trick to define a global level variable that has the address to my stuff rather than setting a working directory, because then you can have more than one, but if you want to do working directory instead, that's fine. In Stata, there is a built-in command called reshape to do the stacking, but it only works if the variables to be stacked have a naming convention that it recognizes. So they have to have like a common stem with like a number after it for it to work. If I had a variable that was called pretest and another variable that was posttest, Stata would be like, I don't know what to do with this. But if I call it occasion 1 and occasion 2, it's like, cool, I got this. So that's one of the limitations of the built-in routines like this. But I am reshaping into long. So wide means 1 row per person, separate occasions for separate variables. Long means 1 row per occasion per person with separate variables and separate columns. But time is a row in this design. So I have to tell it what my level 2 identifier is, which is person ID, and a new level 1 identifier that I'm going to call occasion, and then just this one command does the data transformation for me. So it's looking for occasion and in the data set, and any variable that has that as a stem and then ends in like 1, 2, 3, 4, it would grab all of those. And yes, I have often renamed variables in Stata rather than fight with this, because it's easier to do that. Then I use the gen command to make my 2 new predictors that are centered so that I have time 0, 1 and treatment 0, 1 as well, and throw my labels on there. Okay. Any questions from the Stata folks? All right, then the R folks. That must be everyone else. So I have some good news about R, actually, inadvertently. You know I hate R, right? I'm advertising that. My birthday is coming up, and my husband and family asked me, what do you want for your birthday? Well, like most people, I just buy whatever I want, right? So I have to like make up something. It's like, no, I want a gift from the heart. And so what I settled on is that Jonathan is going to write me my own little collection of R routines to do all the annoying shit that I don't know how to do very well. So if anyone has suggestions for what's going to go into my birthday gift, please let me know. Like one of the things I'm going to ask for when I teach linear models is a sums of squares table that doesn't show up in the LM routine as such. I want the confidence intervals at the end of the parameter estimates like they are in Stata, like just little things like that I want to have. So if anyone has ideas, yeah.
I don't want to be selfish and half it off your birthday gift, but the GLHT, like something like that just messes me up for some reason.
Yeah, the GLHT thing is also unnecessarily cumbersome. So I'm going to add that to my list too, like fix that thing. So I'm excited about that. This is what nerds do for each other for presidents. I've written him a SAS program that writes M+ code for diagnostic models before. That was a present I made for him. So it goes both ways. Anywho, I'm hoping between that and my increasing familiarity with R that it'll be less of an issue. But as I said, I think on the first day, I tend to do things in base R because that's what he prefers, and he's the person I go to most often for help. If you know how to do data stacking in tidyverse or something else and it works for you, Godspeed. Like if you can find a way to do it that works for you, great, do it that way. Here's a way to do it that I've made work. And my promise in this class is that I will never make you figure out something on your own in R that I have not already figured out, because that's just me. Anywho, I am declaring my working directory to be the same place with the weird combination of slashes here that I have come to not understand, but know that it has to be that way. I'm importing the data using a package that has a function called read_sas. I think it's Haven is the package maybe. That's another reason to go to the original files for all of these things. In R, I have all the libraries at the top. And I have code that will install them for you, even if you don't already have them. So it will load and install, depending on whatever system you have that is. That's what it needs. Because I can never tell what I'm going to get when I import data, I always include this statement, even if it's redundant, just to make sure that it's a data frame, because all of these routines tend to use data frames as the data type that goes into the input. Then I found a reshape command. So we start with what the name of the data set is, which I've called wide, because I knew I was going to need to do this right away into a new one. The direction I'm reshaping is into long. I have the names of the new columns that I'm going to be stacking, outcome. The ID variable is person ID, and I'm calling the time variable time in this case. Actually, that should be occasion. That one, I'm going to fix that. That one should be that should be called occasion. I changed my mind halfway through and forgot to fix it. The two outcomes then are the things that are being stacked, and the occasions are 1 and 2. And so then down here in a subsequent step, I did the new variable creation for time coded 01 and treatment coded 01. And because it won't let you label things and still use those columns in certain analyses, I will put my labels as comments instead, so that when you're looking at the file, you know what you're looking at. And then I'm sorting by person because we need that for certain things to work correctly down below. Okay, so yeah, make this word time occasion. I will fix this after class and repost the handout. Otherwise, I believe this should work because I would have run everything already. So any questions on R, getting stuff in, and stacking? Okay. Let me know if anything comes up as you're working with the code in the future. First thing, let's just describe the data. Okay, my mouse does not have as many. Let's see, 300%. Let's go with 200%, see what that looks like. That's a little better. So just getting descriptive statistics. In SAS, I'm doing this with proc means, and I've listed out a whole bunch of them that I want to have here. Tabulate is the command in Stata. So I'm tabulating by group and occasion and then summarizing outcome. The class statement in SAS does it by group and occasion instead. And then in R, I am using the psych package that has a function called describe and describe by, the latter using here to get values per group and per occasion as well. And so then here is the output. So overall, in terms of the grand mean across everybody in both occasions, and then breaking it down by occasion, breaking it down by group, and then finally breaking it down by cell. And this is where the values came from that were on this page. So that's where I got all of that to start with, including their standard errors, which is a reflection of their variance for each type of condition. Okay, so if we just stare at the means, it looked like at the first occasion the groups were relatively equal. They look like they're unequal over time, and it looks like the treatment group grew more. Hooray. Now we'll see if those trends hold up statistically. But it looks like we're going to see if they hold up statistically next time, because it's 142. Stupid computer, you made me lose 10 minutes. But there's always Thursday. All right, so what this handout is going to do is walk you through 4 models, 2 empty models with and without the random intercept. Then we throw in the 3 fixed effects, main effective group, main effective occasion, and their interaction with and without the random intercept, and we see what changes. And not to spoil the surprise, but it's going to matter whether we have the random intercept if we conclude that there's a significant interaction or not. All right, so 143 now. Any questions before we call it a day? Okay, then have a good day. I will see you Thursday. Let me know if you need anything. Office hours tomorrow at 3:30, or you can ask me after class. Bye, everybody. Bye, Zoomers. I'm sorry I kept forgetting to share.